Essentially what I propose is that by massive interconnection with the electrical network of Great Britain and that of the continent, Ireland can become energy independent by using our wind resource, but by connection to the nuclear network that is growing on the continent and the nuclear renaissance that we're experiencing globally, we can become carbon neutral. Now, there are good technical reasons why we shouldn't build a nuclear power station in Ireland. For a start, nuclear power stations come in a standard size, 1 gigawatt, and the largest power station, or the largest generator that we have in Ireland at the moment, is only 40% of that. Such a large nuclear station would cause engineering headaches, to say the least, in actually operating it on the grid. So from a purely electrical engineering point of view, that is the reason we shouldn't build nuclear here, but we should enjoy the benefits that it can offer. So I'm proposing that nuclear should no longer be the bogeyman that it's made out to be by the environmentalist movement, and that Ireland can become energy neutral and harvest our rich resource of wind. Thank you.
David was definitely right to point out that we'll have to change a lot of our energy habits in the future. Emissions would be the main reason for this, but also because the simple fact that our oil, gas resources globally, they're finite and they're going to run out at some point, and we're going to have to at least take some precautionary measures and some transitional measures to move the economy into a more sustainable mode of conduct. So that would be my first point. Just to pick up on the point that David raised himself about the linking with the continent, is that this doesn't need to be solely nuclear. We can link up our renewable energy resources, so we can, obviously wind blows at different times in different places, but the wider our networks, the more that we can connect in with each other and feed off different energy production. By nuclear power, I just want to make clear that at the moment I'm talking about nuclear fission mainly, because that's what we've got at the moment. Nuclear fusion might be achieved in the future, but well, treated as a theoretical kind of outcome at the moment, so we don't know entirely what will be behind that yet, so I'll just deal with what we have at the moment. So when it comes to discussing our energy sources for the future, we must look at all the costs, all the downsides, all the positives to come to a rightful conclusion on it. And we need to look at what we want from our energy. I would say that as the climate change talks go on in Copenhagen at the moment, obviously emissions would be one of the biggest concerns at the moment, especially when we're looking at our long-term future. We also need to look at the finiteness of, if that's a word, of the resources. We need to see, is this sustainable into the future? Can we deal with the ecological and just the clean factual material resources of this? Will it run out? Because there's no point in really changing our energy habits if just a bit further on down the line we need to change them again. It would be very expensive and could be damaging to the economy. Another thing is that we should hopefully have energy plants that are relatively cheap and quick to produce. We need to change quickly, and I would say that nuclear power stations and power plants do take a long time for construction, and there are problems there. And we need to make sure that there is some feasibility of the business model as well. And finally, obviously, we would like energy to be as cheap as we can possibly get it. So if we're switching to nuclear, I just want to point out some of the costs of nuclear power. example of this, because despite the rejuvenation, the political rejuvenation of nuclear power as a supposedly green option, we need to remember that there's a lot in the process of supplying, making of these plants and producing the fuel and the energy that is ecologically damaging and produce a lot of emissions in themselves. There's the vast operation to get the uranium out of the ground, to have it transported. There's the mining, enriching, the transportation, which is polluting and environmentally damaging. I mean, mining is a blight visually and in practical terms. There's also the damage that just building a massive power station its own can do. There are costs, obviously, to building renewable sources as well to capture them, but we'd argue that they're far smaller. Nuclear power isn't without its climate change merits. The UK government's plan to build 10 new nuclear power plants by 2024 would go towards cutting emissions, but it would only cut 4% of emissions. So it's not a spectacular or sparkling achievement. And it's doubtful whether the reactors will be finished in time. A comparable reactor being built in Finland is already going to be 18 months later than planned and will cost €2 billion more. It's also important to note that there's a lot of dependence on the state. On the initial stages, this might not be too bad, but it does continue. The construction phase, in particular, is very problematic. It's important to note that 14 of the current nuclear power plant construction projects around the world are stalled, and that's out of 36. So it's quite a big proportion. In Dr. Mark Jacobson's review of global warming solutions, it was found that nuclear electricity emits between 68 to 180 grams of carbon per kilowatt hour. In comparison, wind and concentrated solar emit between 3 to 11 grams, and geothermal and conventional solar emit between 16 to 64 grams, so quite a bit more. And if emission cutting is our goal, it would probably be best to focus on renewable energy, is my point. Just to quote Nucleonics Week, nuclear may need climate change more than climate change needs nuclear. I'd like to point out that the cost to the taxpayer continues even after construction, because construction is more expensive than production of the energy. It's a bit like that with renewables as well, but the cost to the taxpayer just continues on in nuclear power because of the insurance costs, which are really ultimately borne by the state, given the nature of nuclear power. And it should be noted that £3 billion per year is paid out by the taxpayer to fix bits around Sellafield and contain that kind of damage. I'd just like to say that on the subsidy league table in the UK, in US dollars, about $2.89 billion is spent on subsidising the nuclear industry in the UK. In comparison with renewables only get $94 million. So I think we've got our priorities wrong there. Energy solutions of the future need to take into account the finiteness of uranium